Here we are on page 20 with the numbers 27 through 42. Quite a few of them here, and we're just expected to solve. You'll see exponentials and logarithms, so everything we've learned about the rules of exponentials and logarithms and their domains and ranges will come into play. Number 27. 7 minus 2 e to the x equals 3. Let's start peeling it off. So subtract 7 from both sides and we get negative 2 e to the x equals a negative 4. Divide both sides by negative 2 and we get e to the x equals 2. Good. So now how do we undo e to the? We log base e, or natural log. ln of both sides, and the x comes out front and we get x ln of e is 1, so really those just go away, equals ln of 2. Excellent. Number 28. We get e to the 4x plus 1 minus 2 equals 3. Let's add 2 to this both sides and we get 5 over here. We'll write that down here. E to the 4x plus 1 equals 5. How do we undo e to the? With log base e. So ln, and we get gone. 4x plus 1 equals ln of 5. Subtract 1 from both sides. ln of 5 minus 1. Now, this ln is a function, log base e of 5. It's a number, function of 5, but this 5 can't connect up with that 1 at all. Let's divide both sides by 4, and we get our answer. X equals ln of 5 minus 1 all over 4, and there's our answer. Good. Let's try the next one. Number 29. 2e to the 4x plus 1 minus 3 equals negative 1. Ooh, add 3 here, and we get a 2. So we get 2e to the 4x plus 1 equals 2. Divide both sides by 2, and we get e to the 4x plus 1 equals 1. So we can log base e both sides to undo that exponential. That's gone. We get 4x plus 1 equals, now ln of 1, that's something we know. That is always 0. Any log, or log of any base, of 1 is 0 because e to the 0 power is 1. Well, we can solve this. 4x equals a negative 1, and then x equals a negative 1/4. Good. Number 30. We have 10 plus 3e to the x equals 5. So we subtract 10 from both sides and we get 3e to the x equals negative 5. Divide both sides by 3. E to the x equals a negative 5/3. And we're going to natural log both sides. At this point you may be thinking, wait a second, something looks a little bit odd. And yes, if you were to try and stick this into a calculator with a negative in there, it'd give you an error. You're like, bzzzt, thanks for playing. Yeah, our domains of logs were only positive numbers. There's something going on here. Let's look a little bit deeper. E to the x was a function that looked like this. Its range only extended to the positive numbers. It never hit 0 and it never hit negative numbers. So e to the x equaling a negative 5/3 would never happen. There is no solution, certainly not in the real numbers. So that's something we have to be careful about, is that we can never take the log of negative numbers or 0. Good. Let's look at the next one. Number 31. This one, e to the 2x and e to the x, we can't combine those. We were able to, in these first 4, start peeling stuff off, kind of like an artichoke, just peeling off those outside leaves by inverse functions. Here, this one is this one squared, which means that this is much like a quadratic. We're going to put a mask on there, let u equal e to the x, and what does it look like now? Well, it's u squared, that's e to the x squared, plus 4u minus 21 equals 0. We know how to solve this guy. U plus 7, u minus 3, we factor those out and we get u equals a negative 7 and u equals a positive 3. Now let's take that mask, this mask that we created, back off so we can solve for x. E to the x then has to equal a negative 7. E to the x equals a 3. Well, negative 7 was never in the range of y equals e to the x, so that one will produce no solution. But this one will. We can natural log both sides, log base e, and we get x equals natural log of 3. Excellent. Let's do number 32. Again, we have an e to the x here and an e to the x squared. So e to the 2x right there. So let u equal e to the x. So we get u squared minus 8u plus 15 equals 0. Hey, we know how to solve that one. We get u minus 3, u minus 5, and u equals 3, u equals 5. Take this mask off and we get e to the x equals 3, e to the x equals 5. Both of those will produce solutions. So we just do a, how do we undo e to the? We log base e both sides. That's ln of both sides. And we get x equals ln of 3 and x equals ln of 5. So we get 2 answers on that one. Good. Now let's try the next one, number 33. Looks like we have the same kind of situation. Let u equal e to the x. And we get u squared plus 2u minus 24 equals 0. So what does that give us? That'll factor with a u there and a u there. And we get plus 6 and a minus 4. Good. So we get u equals a negative 6 and u equals a positive 4. Take this mask off. U was e to the x the whole time, so we get e to the x equals a negative 6, e to the x equals 4. This one will produce no solution. E to the x only gives us positive numbers. E to the x equals 4. We can log base e both sides, and natural log of e to the x is x equals ln of 4. Good. Number 34. We're in the same situation. Let that be a u, and so that's a u squared. We get u squared plus 8u plus 12 equals 0. Now let's write that out. Let u equal e to the x. Good. Now when we factor this, that's nice. I like that this boils back down to things that we've done before. U plus 6 and u plus 2. So we get u equals a negative 6 and u equals a negative 2. So let's take that mask off and we get e to the x equals a negative 6 and e to the x equals a negative 2. And yeah, we have a problem. This never happens. Let's again look at that graph of e to the x. Looks about like that. The domain was all real numbers, but the range, it only hit numbers up here. Well, it'll never hit a negative 6 and it'll never hit a negative 2. So this guy is going to end up with a no solution right there. Okay, let's move on to number 35. This is a logarithmic equation. We got to get to these x's, so we got to undo this log. What's the opposite of logarithms? Exponentials. So we got to do a 3 to the and a 3 to the. That sounds like a weird operation, but it's 3 to the log base 3 of this equals 3 to the 1. Or some people use the definition and say this base to that exponent equals this. Either way, we will get x squared minus 5x minus 21 equals 3 to the first power. Hey, we can solve this as a quadratic. Subtract 3 from both sides, so we get x squared minus 5x minus 24 equals 0. We can factor this guy, x and an x. That's a minus 8 and a plus 3 equals 0. Then we get x equals 8 and x equals a negative 3. All right, let's just double check. We can never take the logarithm of a negative or 0 number. So let's stick them back in and let's make sure we get that. We get 64 minus 40 minus 21. That'd be log base 3 of 3 equals 1. Good. Okay, now a negative 3. Let's try that. X squared, so that's positive 9 plus 15 is 24 minus 21 is 3. And indeed, you could tell that this would work. We solved and found the numbers where this equaled a positive 3. So this guy right here was going to equal a positive 3. We were actually in no danger of getting unusual solutions. So let's try it with number 36 now. Log base 2 of this equals 4. So we exponentiate by 2 on both sides. And we get x squared plus 8x minus 4 equals 2 to the fourth is 16. And notice we'll find the numbers here where this is a 16. And if that's a 16, we're going to be fine. We'll always take the log of a positive number. We're solving a quadratic, so we need to get it equal to 0. So x squared plus 8x minus 20 equals 0, subtracting 16 on both sides. Factor, and we get an x and an x, and that's going to be a plus 10 and a minus 2. X equals a negative 10 and x equals a positive 2. And these numbers, when we stick them back in here, will give us 16, and log base 2 of 16 is indeed 4. So both of these answers work in that one. Great. Number 37. So we're going to exponentiate by 3 on both sides to undo the log, and we get x squared plus 3x minus 13 equals 3 to the third power is 27. This is a quadratic. We've got to get it equal to 0. Subtract 27 from both sides. We get x squared plus 3x minus 40 equals 0. That guy factors into x plus 8 and a minus 5. Is that right? It is. So we get x equals a negative 8 and x equals a positive 5. Oh, good. And that will give us the numbers that give us 27 in here. So log base 3 of 27 will indeed equal 3. Good. Number 38. Log base 2 of this equals 5. Yeah. Exponentiate by 2. I'm not sure that's a real official math word, but that's what we're doing. We're raising both sides to the power of 2. So that will cancel, and we get x squared minus x minus 10 equals 32. Subtract 32 over, we get x squared minus x minus 42 equals 0. And then factor x minus a 7, x plus a 6. That's going to give us x equals 7, x equals a negative 6. Okay, both of those will then work. Great. Now we get to some interesting ones. Number 39. Notice we can't just exponentiate by 2. That's not a distributive operation. So we have to combine these into one logarithm. So we know how to do that. This is a plus sign here. We can use that to write it as log base 2 of x times x plus 2 equals log base 2 of x plus 6. Hey, now we have it as one logarithm on each side. We can exponentiate by 2. Done, done. And we get x squared plus 2x on the inside here equals x plus 6 over here. Hey, we know how to solve this guy. Subtract, we get x squared plus just 1x if we subtract an x over, and subtract 6 over, and we get 0. So we can factor this to x plus 3, x minus 2, it looks like. And so we get x equals a negative 3 and x equals a positive 2. Now we do have to watch out. There's a concern here. You'll notice that in these individual logarithms in the original equation, the x right here, the x plus 2, we have concerns as to whether or not some of our answers will work. This guy says we can only have positive numbers stuck into this logarithm. This one says we have to have anything bigger than negative 2, and this one says we have to have anything bigger than negative 6. So you'll notice that this one right here, if we try to stick that into that one right there, we'll break it. You cannot take the logarithm of a negative number, and so that is not doable. A 2, however, fits into all of them. We could take log base 2 of 2, log base 2 of 4, and log base 2 of 8. And it works. Log base 2 of 2 is 1, log base 2 of 4 is 2, and 1 plus 2 indeed equals log base 2 of 8, which is 3. Yeah, that would work. So x equals 2 is a solution. This was an extraneous solution we picked up by getting that coming out when we combine the logarithms. All right, number 40. Same situation. We're going to combine these into logarithms using one logarithm using our rules. So we get ln of x times x squared minus 15. Ooh, that's going to be a cubic when we get there. Ln of 10x. All right, so how do we undo natural log? Well, we take e to the. This is base e, so we e to the both sides. We get x cubed minus 15x equals 10x. All right, so far so good. We can solve this. Subtract 10x from both sides to get it equal to 0. We get x cubed minus 25x equals 0. And factor an x out. We get x squared minus 25. Oh, that's a difference of squares. That just makes your heart happy, doesn't it? That's an x plus 5, x minus 5. All right, so that equals 0. So we have as our answers x equals 5, x equals negative 5, and x equals 0. We got 3 of them. Some of them may or may not work. Let's check them back up in here. We have to have 0 or positive in this one. So that, I mean, we can't have zeros or negatives. We can only have positives in the first one. So a 0 is out and negative 5 is out. Now let's see if 5 will work in this one. Let me see, ln of 25, right? 5 squared. Can we put a 5 here and a 5 here and a 5 here, and all the logarithms turn out to be good? Yes, that's a ln of 5, and ln of 25 is ln of 10, and ln of 50. All right, yeah, that one's going to be a solution. Good. Okay, the last two. Let's go to number 41. We've got this similar situation here. Let's combine it. Ln of x times x squared minus 8 equals ln of 8x. If we e to the both sides, we get those cancel, we get x cubed minus 8x equals 8x. It's a polynomial now, so we can get it equal to 0. X cubed minus 16x equals 0. Now factor. There's a common factor of x. We get x squared minus 16. Oh, that's a difference of squares. That's nice. X times x plus 4 times x minus 4 equals 0. We get x equals 0. X equals a negative 4, and x equals a positive 4. So let's look to see if all of them fit in. This particular logarithm will only allow positive numbers in it. Natural log of only positive numbers. So the 0 is gone. We can never take the ln of 0. And we cannot take the ln of negative 4. You should try those in a calculator sometime. See what it does to your hand. And then does the 4 actually work? Ln of 4. Ln of 16 minus 8, that'll give us a positive number, and 32. So, yep, that one will work. And you can actually plug those in to see what will work. You'll have ln of 4 plus ln of 8 equals ln of 32, and punch those in a calculator. It'll actually come out to work. It's like magic. All right, number 42. Last one here. Okay. So we've got separate logarithms, so we need to combine them. So we have log base 4 of x plus 5 times x minus 7 equals 3. Okay, undo the logarithm, 4 to the, or use the definition of logarithms, and you'll get this side will be x squared minus 2x minus 35 equals 4 to the third power is 64. Wow, okay, so let's subtract 64 from both sides, and we get x squared minus 2x minus 99 equals 0. Hey, look at that. That factors. X and an x minus 11 plus a 9, I believe. So we get x equals a negative 9 and x equals a positive 11. So let's double check that both of these answers will actually work. If we stick them in here, negative 9 plus 5, certainly 11 plus 5 will give you a positive number 6, and positive number 4 will work there. So 11's good. Negative 9, when you put it in here, negative 9 plus 5 is a negative 4. That won't work. So negative 9 in there does not work as an answer. So 11 will work. And just to write that out, we have log base 4 of 16. Oh, I said 6 before, is 16. Log base 4 of 16 plus log base 4 of 11 minus 7 is 4. So that's a 2 plus a 1 equals 3. Hey, look at that. That was pretty cool. All right, good.